Hey, good afternoon, everybody. My name is Patrick Jones, and this is a Tamer's surface and diameter inspection webinar. I think we're still waiting on a few people here, so we'll just kind of wait it out a few minutes. So for you guys who haven't used this application before, there should be a little kind of box in the corner of your screen there that has 4 buttons. In that, if you don't press that after a while, it'll kind of disappear. Don't worry, it's just if you want it to reappear and ask a question, you just click the little arrow on the top button there. It'll reappear and you can ask a question or yeah. But we'll just give everybody about maybe another 4 or 5 minutes here. Okay, guys, I'll start in about a minute here. We're just going to wait on a couple more people, and we'll get going. Okay, so yeah, let's get her going here. So yeah, first off, good afternoon, everybody. So this is Tamer's surface and diameter inspection webinar. My name is Patrick Jones. I'm one of the sales engineers here at Tamer. Along with me here is Alex Kozalchuk, one of our vision engineers.
Hello. Hi.
And yeah, so just what I was saying before to everybody, just as an overview, you should have like a little tiny little box with 4 buttons on it. That little box will disappear but if you want to have it reappear, there's the top orange arrow there. If you click that, it'll pop back out and you can type in any questions. And so kind of the general format for this webinar is I'm just going to go do a very quick overview of like us and of Tamer, and then we'll go right into the UI on the SI. We've got like a test cable running through the SI right now, and we'll go through the UI and the different functions of it. And so for the purpose of this webinar, if you have any questions, go ahead and type them in and ask them. I'll try to answer them, some of them as I go, and most of them I'll probably go through at the end of the webinar. I plan on taking probably about maybe half an hour here just to go through everything, and then we can go through any questions. Yeah, and so without any further ado, I'll get started here. So for those of you who aren't as familiar with us, so Tamer, we actually we're global, and we basically started out actually making hot foil printers. And we also produce length counters, and then we ended up getting into vision systems, and that's the primary portion of our business right now. And so today we'll be looking at the system in the center here, the SI3100 Surface Defect Inspector. So it's basically a 3-camera system that inspects for lumps, neck downs, diameter changes, and for surface defects on your cable. Yeah. So basically, in general, kind of defects you guys, in the wire and cable industry are dealing with: pinholes, fish eyes, lump, neck downs, scratches, and any other kind of sort of imperfections. And basically, SI is designed to look for those defects. So just quickly here, comparing it to a spark tester. So any sort of pinhole that's not a through hole, the spark tester may not pick up. It's not going to work with any products that don't have a core, and the operator can't go back and evaluate the size and severity of the defect. Whereas with the SI, you're going to get a picture of that pinhole. If it doesn't go to the core, it's still going to catch it because it's on the surface. And anything that doesn't have a core, it can inspect because it's just looking for defects on the surface of the product. Similarly, just comparing it quickly to laser gauges. So laser gauges, you have a constant scan rate, whereas the SI is going off of basically the line speed or an encoder signal. And so the actual scanning from the camera is based off of your line speed. So depending on, so if you ramp up or slow down, the scan rate will adjust to that. And so as well, the SI is capable of looking at a multiple number of things. So diameter, a lump, neck down, and surface defects as well. And the biggest portion of it is that you get that image, you have a timestamp telling you where in the run that image was taken, and when it was taken, and you can actually see the defect. Okay, so going into the UI here. So this is the main screen of the UI, and so like I said earlier, we have a test cable running through an SI3100 here in our lab. And so in general, for your guys' processes, usually you would place the SI on your extrusion line, ideally prior to the printer, and to inspect the surface of the cable. And so, yeah, and so looking at it, we've got the main screen here, and so these are the 3 different camera views that are running in real time right now, being displayed on the left here. And on the right, it'll show like the last defect image. So quickly, if I hit start here and running, it'll slowly, once it detects a defect, it'll pick that up and show it here. So on this cable, we have a few mock defects on there with tape or other defects. And so once it catches something, it'll pop up here. There you go. And then on the right here is the category. So the category is basically what you use to select based upon the different product that you're running. So if you're running, let's say you're running a 1/4 inch cable, you'd have a category specific to that cable that you'd set up, and you'd change the category when going over to something like, say, a 1 inch cable, and so each cable is going to have its own category, and some cables may be able to fall into the same category if they're very similar. And cable ID is basically the for each run. So if you're going from one run to the next, the cable ID is what you would generate for that run. And so you can either either set your cable ID by typing it in, or you can have it automatically generate a new cable ID, and it will generate that for that run. Below that, we've got camera control. So camera control basically just controls the field of view. And as you can see, as we're running here, the field of view is automatically adjusting itself, to keep the cable centered. So generally speaking, you don't really need to touch this, but as you can see, if I click on this one here and I move it off in one direction, you can see the field of view on that first camera is going to, take out the cable there. But if that happens, you just hit find cable and it will go back to center. But generally speaking, you really don't need to play with this. And below that, you've got the speed and the length on the cable. So that's going off of, in this case, an encoder signal. And that's being displayed in real time. And then below that, we've got basically our diameter measurements. So the diameter measurements are being measured over each individual axis. So each axis being each camera view, and those are being measured in real time. And then the average is being averaged out over about a 5-meter interval. And then as well, you also get the ovality, the min and max diameter being measured, and your standard deviation. Of course, if there's anything additional, any sort of additional statistic you want to add, we can modify that in the software to include it on that screen. And then below that, you've got your defect counter, which basically tells you how many defects of each type you've had in this run. And this is the main tab, and that is what you would look at from a day-to-day perspective. The next tab that we look at is the view defect tab, and the view defect tab is going to show you each of the individual defects captured. And so in this case, these images have been kind of stretched out just to fit the actual display. If you were to pull up this image on your computer, it would be a little more compact. But basically looking at this defect image, on the left, you've got the image taken by the camera. And on the right is the processed image that has been straightened and detected. And so, right here, we've got the defect circled, and that's what's been caught. And below that, you've got your timestamp that shows you, the image name, the cable ID, and note that the cable ID is basically where that image is going to be saved under. So a folder is going to be created on the PC or in your network, depending on your integration requirements, and it's going to be saved in that folder. And it's going to give you the position that the defect was caught at, and the type of defect, and the date it occurred, and the approximate size of the defect. And then as well, you can actually view a directory of all these different defects that have been recorded in the past. And these are also saved on the PC or in your network as well under their respective folder for the run. Okay. And then so I guess the next step really is how do we set up our category. So and ideally you would be able to set these up primarily when you're first commissioning machine. But of course, if you have new products or new SKUs, so how do we go through and set up a category for that new SKU? And this is all done underneath the initial setup tab. So right here, you can see we've got our category selected, it's demo. And the first thing we would do is actually look at the exposure and the gain. So the exposure basically what that is, it's dictating how much light is getting through to the sensor. And so you can see when I adjust this, it's going to get, if I go really high, the image is going to become extremely bright. And similarly, if I go really low, it's going to become very dark. And so this is kind of the first thing that we adjust when you're setting up a new recipe, is that exposure and gain. And similarly, the gain is basically just kind of amplifying that signal. So if it's really low, it's going to become really dark. Again, high, it'll become bright. And so when you're setting up a recipe, that's the first step. The second step is kind of dictating what configuration you want. So for certain applications, you may only want to detect surface defects, or you may want to ignore the surface completely and just look at the lump and neck downs only. Those different configurations are possible. And below that, when it says bright on dark and dark on bright, it's basically dictating the type of defect detected. So, for instance, if we have a bright spot that appears here on the cable, that would be a bright on dark, and that would be caught as that, as a bright on dark. Similarly, if you have a really dark spot caught on the cable, that's a dark on bright. And so for most applications, you end up using both. For specific applications, you can sometimes go to a certain configuration. Similarly, below that, if your cable has a stripe on it, you can also configure it to inspect with a stripe. And so when we look at our display here, right now we're looking at the normal view that you look at when you're viewing the SI. And so below that, the next kind of thing you would set up is the cable outline. And so your cable outline right here is basically looking at the edges of the cable. And so when you're looking at the edges of the cable, that's basically what's going to determine your diameter measurement, lump and neck down as well. And what you want is to be able to see the edge completely. So, but if we lower this a lot, what you're going to see is, that it actually shows, too much. It's actually filling in the whole entire cable, which we don't want. We actually just want to see the edges. And if you increase it too high, eventually the edges are actually going to disappear, and you're not going to get an accurate reading on your diameter. So below that, we also have our ovality tolerance. So basically for calculating our ovality, and basically what that's looking at is between two different camera views or two different axes, we're basically looking at the two diameters and subtracting one from the other to give us the approximate ovality. And that's what was shown on that main screen, that first chart we looked at. Below that, the length tolerance is basically setting up what your lump and neck down is going to be measured over. So if you're looking at, if your lump tolerance is 39.4, it's going to look for a change in 39.4 thou over 0.12 inch. And so that's just basically dictating that lump and neck down length that you want to inspect over. Similarly, OD tolerance, like I mentioned before, OD is actually, it's kind of hardwired into the system to measure over a 5 meter interval. And similarly, you can set that spec for the high and low end of it in right below the x-axis here. And so then the next kind of step, once you've figured out your diameter measurements and what you want to set it at, is to look at the surface defects on the cable and what you want to inspect for. So this is all done under sensitivity. So our sensitivity in this case is actually fairly high. It's at 80, but if we increase that to an extremely high amount, you'll see that we'll actually start detecting the entire cable, which is not really what we want. So this sensitivity, when you adjust it, it's basically going to dictate what point of interest you want to detect. And so when you're first running the product through, there's a little bit of trial and error when you're first putting the product through the system to see, okay, is this what we consider a defect, or is this good product? And that's usually done over like just the first few lengths of cable. And of course, you can also set up the actual defect size that you want to detect. So, and that's done through this, this gauge here. And so you apply these settings, and you can actually run with the product like that. And see if your changes actually start detecting defects or not. And then we can do that through the straighten cable section. And so if I increase this to, let's say I increase it to 100, start detecting everything basically. And so this page basically allows you to set up your recipe however you'd like. And then you always have to make sure you hit apply after, and it'll save all your settings under the category. And then you can use that category for your product. So that's basically just kind of the overview of setting a recipe. And after that, we have both the service and integration tabs. I won't go into too much detail on either one of those tabs. But basically, we're able to integrate with a number of different PLC systems. So in this case, we've got ControlLogix and Logic Selected, and if you guys want to have a certain output from the machine, you can have it output. So for instance, let's say you want to have an alarm every time you catch a surface defect. You can have it output to an alarm signal and have it go off. Or you could also, similarly, we can actually hook up the SI to an external monitor. So say your operator workstation is, further down the line, you can have an external monitor that's hooked up to the SI, and they can view it from that external monitor or from some other control room. And so basically, depending on what kind of integration you want, we're able to integrate your systems. Alex and our other controls engineers are familiar with a number of different PLC systems. And I know more and more as people automate, there's definitely a need there to provide that additional level of integration. Okay, so I guess that's kind of the general overview of the webinar for today. And so I'm going to kind of just open up the floor here for any questions if everyone has any questions to ask. Yeah. Let's see. Oh. Let's see. Oh. Try this again. Okay, so you guys can unmute yourselves if you'd like. That's what that means there. There we go. Okay. I guess I can do it individually. Sorry, guys, I'm just kind of going through it and muting everyone here. Sorry, guys, anyone have any questions? Or if you want to answer any questions via the text, feel free. Okay. There we go. Just give me a sec here. The little question tab is a little painful to read right now. I don't know why this is. So the first question I have is, do you have support options for existing equipment that was purchased in the past? Yes, we do. So in general, usually when we've had people reach out to us who've had older machines, usually we can actually go online to support you guys remotely, or if you'd like, we can actually set up a visit to help support your system, depending on if you require hardware to be replaced. But if your system is online, usually we're able to remote into your system and help you get it set back up. We have had that happen in the past before. Especially if you're moving a system over from one line to the next. So usually we're able to work with you guys on that. And then so I got a question here for, have you ever integrated this with Adveris for reporting? We're gonna leave that one to Alex. I don't know, Alex, have you ever integrated with Adveris?
No, I don't think I've ever heard of Adveris. We can check if anyone in the past has, but yeah, no, this is actually the first time I've heard of that. So I'm not too sure what that is actually.
Yeah, so Tim, in general, we've had a number of times where we've had some new system come up, when we have been able to work with the customer to integrate with it. Especially now, I mean, a lot of people are actually going into putting in place new MES systems, on their production line, and so it's not unusual if we have a new reporting system or master manufacturing execution system to integrate with. So it's got, off the top of my head, I'm not sir if we have. I know Alex said he hasn't, but it's something that we can definitely usually, I mean, I'd say 95, 98% of the time we're able to integrate with a different system. Okay, so next one is from Dennis. So can you stitch together the 3 camera views to get a 360-degree view of the cable? So these camera views actually are stitched together. So you actually are getting a 360-degree view with these 3 camera views right now. So there actually is a little bit of overlap between the views, and so you actually are getting 360-degree view. So that this is 360 degrees around the cable. So when we're looking at defects, we are looking at 360 degrees of the cable.
Yeah, and if Dennis means just in the view, so seeing it stitched together, there is options to stitch the full image into so it kind of looks like the product unrolled in a way. Usually we use this kind of thing for print isolation. That way, if the print kind of goes off the side into another view, we can still stitch it together to get a full view of the print. But this, that definitely is an option. You can enable that to see just a 3 image stitched together.
Okay, go on the next image here. Have you had any success in lead extrusion will detect deformations or pinholes in it? So we've had a couple applications now with dealing with lead extrusion, and so we've had a couple, and it's definitely an application that requires a little work on our end for the lighting setup, and there's a little more, because of the shine off of the product, I guess there's a bit of glare. So we do have to do a bit more work on the lighting. But we have been able to implement different projects with light extrusion in the past. And in general, like when we're, especially, in any application, and especially in this case, that's why we like to see samples prior to actually applying or even quoting the unit, because it allows us to get a better sense of the feasibility. And that's kind of part of the process, is we usually get samples and perform a feasibility study prior to quoting for that reason. But yes, we have had applications with light extrusion. We actually have one very recently here that we're going to be commissioning pretty soon. Okay. So can you use a system with profiles that are not round? Yes, you can. And actually we've had, so I'm just gonna repeat that question. Can you use a system with profiles not round? And the answer is yes. We've had applications in the past where I've actually had an application where we were inspecting a strip that was used for razors. It was actually the razor strip that you use that touches your face. And so it was actually shaped like a T, and we were inspecting it for dimensional tolerances. Similarly, in the wire and cable industry, if you're looking at flat cable, we can also inspect that. Usually for these types of applications where you're dealing with a product that isn't round, we generally need to use the 4-camera system rather than the 3-camera, just to ensure that we have all the correct views. So yes, we can inspect systems with different profiles, but the razor strip was probably the most interesting one I've seen in a while. Yeah. The next one, can this system identify high legs in cabled 3-strand product? So I think, Paul, I'd probably have to clarify what you mean by high legs. I'm assuming you're referring to basically like a kind of a lump caused by one of the cables kind of coming out of the bunch there.
Yeah. Hey, can you hear me?
Yep.
I'll talk through this one. So yeah, we have 3 single conductors that we would cable or twist into a single three conductor cable. And so identifying if one of those conductors is further away from center line than the others prior to putting it through an extrusion process to cover it with insulated material. Identifying those high legs is a manual process for us right now.
Yeah, and so I guess the way we'd probably go about doing that, and Alex, feel free to step in here, is we'd probably look at the diameter of that cable as it's being inspected, and if that edge kind of comes out as like kind of a lump, out of from the center, you could detect it in that manner.
Yeah, or likewise, if there's a gap caused by that, if I'm picturing the defect correctly, there could also be instead of a lump, it could be a neck. If say there's a distance between the conductors, that could get picked up as well as like a neck down almost, as opposed to a lump. But
yeah, the challenge that we see is that because the OD fluctuates in and out, with every twist, a lot of systems struggle to identify when, one opening of the OD is a defect versus, the norm, if that makes sense.
Mm-hmm.
I mean, imagine looking at a rope, right, and it's got that twists in it. Well, it's not perfectly symmetrical. It's it moves constantly. So a lot of systems have a trouble identifying that as a okay process.
Actually, I'm going to take a step back. Actually, I think kind of the way we would actually do it is using kind of, I don't know if it makes sense, but wrap inspection, kind of looking at the, perhaps the lay length between, you know, when you're looking at, you know, the wrap on that cable, because I imagine that would be, the laying length would be actually changed when you actually have that defect, correct? Or?
Sorry, I get your question. What would you say?
Sorry, so basically, rather than looking at, you know, like the diameter and the surface of the cable, potentially we could actually look at the lay length between the wraps and kind of inspect it in that manner. So
that might work. I'm not sure. We'd probably have to send a sample and just see if you guys could figure out an option. And we actually do have a system here that's on a different line that we are looking at moving over to this to identify this problem if it works.
right. Yeah, even if you send us an email or samples, that'd be great. And that way we can take a look at this. But yeah, I'll make a note here, Paul. So why does camera? So for Dennis, why does camera 1 image look wider than 2 and 3 images?
That's pretty much just how it's set up here. The camera 1 is actually slightly closer in our test setup bench here than the other 2. So that's why it's a little bit larger in the frame there. But yeah, in the actual SI systems, all the cameras are equidistant from the center line. So all of the images should look the same in the on the actual production line. This is just kind of our test setup we've been playing around with and moving cameras back and forth. So one ended up a little bit closer than the other 2, but yeah.
Okay, I think that's all the questions I see here. I don't know if anyone else has any other questions here they wanted to ask. And of course, if there's anything else that you thought of afterwards or wanted to ask after, you can always send us. You can also send us an email or reply to that initial invite. And I'll send out a kind of like just an overview of, you know, some of the questions answered that we had today, you know, just for your guys' records. And yeah, so thanks for joining us here. I hope we were able to go over, you know, everything and kind of give enough time for you guys to process everything here. And yeah, have a good rest of your day here. And oh, sorry, the only other thing I was going to mention too is if you actually want to have a one-on-one demo, feel free to reply to that email I'm going to send out, and we can set something up where if you want to have more members of your team join and we can talk about your specific application in more detail. You know, we can set that up after, you know, sometime after this webinar here. So feel free to reply to the email. And so yeah, if there's no more questions there, I'll turn this off here. And again, thanks for joining us and have yourselves a good day. All right, thanks.